Hi, welcome to week 2. This is Algebra 1, and this week we're going to start a new topic, which is graphing quadratic functions. Okay? So first off, what is a quadratic function? Okay? Well, to relate it to our last unit, a quadratic function is going to be a polynomial of the second degree. Okay? So that means it's going to have like a second degree term to it, and there might be a coefficient in front of that term. It's going to have a first degree term in it, possibly, with a coefficient, and maybe a constant, which we'll call C. Okay. So all the equations, the functions that we're going to be graphing, are going to have this kind of general structure, right? A second degree term, perhaps a first degree term, and perhaps a constant. Okay. When we write it in that order from highest degree to lowest degree, it's called the standard form. All right, so we're going to break graphing down into 4 steps. The first step is going to be to identify something called the axis of symmetry. Okay, so find the axis of symmetry. Okay. Let me grab a book real quick, just so you can see what these sort of graphs are going to look like. Okay. All right. So here is what quadratic functions look like when you graph them, right? So they're kind of shaped like a U, like the letter U, sort of. And you can see that all these graphs are symmetric, right? The left side is the mirror image of the right side. Okay. So a key strategy in graphing this is to try to find this point here in the middle of the center, right? For all these graphs, it happens to be the low point. All right. So we want to find that point first. It's pretty essential to graphing this. All right. So to find this axis of symmetry, we're going to use this formula: x equals negative b divided by 2a. Okay. So b refers to the coefficient on the first degree term, and a refers to the coefficient on the second degree term. Right. Once we find that x coordinate, okay, what we're going to do is create a table of values centered around that x coordinate. Okay, so create a table of values. Okay. So you can see in problem number 1, we're going to find 5 ordered pairs. Okay. Right. So once we find all those values, we're going to plot the ordered pairs. Ordered pairs. Okay. And then sketch the graph. So at this point, it's pretty similar to graphing linear functions, right? For a linear function, we make a table of values using the equation. We plot the points, and then we connect those points with a smooth line, a curve. Okay. So the only kind of new thing here is kind of finding this axis of symmetry coordinate, okay, and then using that to determine what values to use in our table. Okay. All right. So let's look at example number 1. Use the steps listed above to graph the quadratic functions. Okay? So this function is simply x squared. Okay? So I can think of this as having a coefficient of 1 in front of the x squared, a coefficient of 0 for the first degree term, and a coefficient of 0 for the second degree term. All right. And so I can kind of name these coefficients. This is the A coefficient, this is the B coefficient, and this is the C coefficient. All right, so our axis of symmetry is x equals negative b over 2a. So that's going to be negative 0 divided by 2 times 1. And that's just simply 0. All right. So this is going to be kind of the middle x value in our table of values, right? We want to have x equals 0 and then choose two integers that are just smaller than 0 and two integers that are a little bit larger than 0. Okay. All right, so we'll just go down -1, -2, go up +1 and +2. Okay. Now, not every table of values is going to have 0 in the center, right? That's all determined by this axis of symmetry formula. All right, so now that we have these 5 x coordinates, let's produce the y coordinates by using the function. Okay. So before I wrote all this other stuff, the function was simply just x squared. Okay. So we're going to have -2 squared, -1 squared, 0 squared, +1 squared, and +2 squared, right? And then I'll just use my calculator to produce the y value. Okay. Or these ones we can just do in our head. So -2 squared is just -2 times itself, so +4. This would be +1. This would be 0. This would also be +1. 2 squared would be 4. Okay. So I just added an extra column there, okay, with the y coordinates. Okay. All right, so now let me plot these coordinates, right? The first point is going to be x -2, y 4. Right there. Okay, and then x -1, y +1, x0, y0, x1, y1, and then x2, y4. Okay, and you can see that those 5 points, right, are just kind of making the outline of that U shape, right, the one that I showed you from the textbook. Okay. So now we'll just draw a smooth curve that passes through those 5 points. 1, 2, 3, 4, and 5. All right, so there's one thing in this example that I kind of glossed over, which is this thing called the vertex. Okay. Now the vertex is going to be that singular point there at, in this case, the bottom of the curve, right? It's the point that doesn't quite belong to the left side, doesn't quite belong to the right side. It's the point that's kind of in the exact middle or center of the graph. Okay. And so that point had coordinates 0, 0. So we would write 0, 0 as the vertex. All right, let's go to the next page. And we've got another example. Now this function is second degree polynomial, but it has 2 terms, whereas the first example we did only had 1 term. All right, so this is the same as 1x squared plus 0x minus 4. Right, so that first degree term is technically not there, so we can write it with a coefficient of 0. Okay. All right, so I'm just going to label this as the A coefficient, 0 is the B coefficient, -4 is the C coefficient. Okay. All right, and then now we'll calculate the axis of symmetry. All right, so the formula is x equals -b over 2a. All right, so the B coefficient, that's 0, and the A coefficient is 1. So -0 divided by 2 times 1, which once again is 0. Okay, so that means for our table of values, we're going to put 0 as the middle x value. Okay, and then choose 2 integers that are less than 0, like -1, -2, and choose the next 2 integers above 0, 1 and 2. Right. Next, we're going to substitute these x values into our function x squared minus 4. Okay. So we'll have -2 squared minus 4, -1 squared minus 4, 0 squared minus 4, 1 squared minus 4, and 2 squared minus 4. Okay, and then I'm just going to add an extra column where we'll record the final y coordinate. So -2 squared minus 4. Okay, so we could do it by hand. I'm just going to choose to use the calculator at this point. Okay, -2 squared minus 4 is 0, right? negative 2 squared is 4, and then you subtract 4, you get 0. Okay, negative 1 squared minus 4 is negative 3. 0 squared minus 4 is negative 4. Okay, and then what do we have? We have 1 squared minus 4, which is negative 3. And then we have 2 squared minus 4, which is 0. All right, so we'll take these ordered pairs, plot them in our coordinate plane, and then identify the vertex point. Okay? So x negative 2, y 0, x negative 1, y negative 3, x 0, y negative 4, x1, y negative 3, and then x2, y 0. Okay, so no surprise, we have that kind of U shape being outlined by these 5 points, and we'll just connect them with a smooth curve. Okay. So here, why don't I use a highlighter here? So the vertex refers to that unique point, right? The point that's right in the center of our curve. This is actually called a parabola. I don't know if I've mentioned that in the video yet, but this shape that we get is called a parabola. Okay? So that point there has coordinates 0, negative 4. Okay. All right, so we've graphed 2 quadratic functions already. Let's do a third. Okay. Now the third one, you can see the function has more terms. There's a second degree term, a first degree term, and a constant term. Okay. I'm going to make one slight modification, and I'm going to write a negative 1 in front of our second degree term. Okay. All right, so let's go ahead and label these coefficients. Negative 1 is the A coefficient, positive 2 is the B coefficient, and positive 3 is the C coefficient. So let's calculate the axis of symmetry. X equals negative B over 2A. All right, so that's going to be negative 2 divided by 2 times negative 1, right? I substitute the B coefficient in the numerator and the A coefficient in the denominator. All right, so that's negative 2 divided by negative 2, which is positive 1. Okay. So now I'm going to choose positive 1 to be the center value in my table of values. Okay. And then we want to choose the 2 integers that are smaller than 1, so 0 and then negative 1. And then the next 2 integers that are bigger than 1, which would be 2 and 3. Okay. Right. And now that we have 5x values, we'll substitute them into the function to produce the y values. So we're going to have the negative of negative 1 squared plus 2 times negative 1 plus 3. We'll have the negative of 0 squared plus 2 times 0 plus 3. The negative of 1 squared plus 2 times 1 plus 3. The negative of 2 squared plus 2 times 2 plus 3, and the negative of 3 squared plus 2 times 3 plus 3. Okay. All right, and then let's record the y coordinate at the end. All right. So let's see here. We've got the negative of negative 1 squared plus 2 times negative 1 plus 3. Okay, and that's 0. And then we're going to have the negative of 0 squared plus 2 times 0 plus 3. That's 3. And then we'll have the negative of 1 squared plus 2 times 1 plus 3. That's 4. And then the negative of 2 squared plus 2 times 2 plus 3. That's 3. And then the negative of 3 squared plus 2 times 3 plus 3, which is 0. Now, I don't know if you've noticed this when we're completing the table of values, but the first and the fifth y-coordinate end up being the same. The second and the fourth end up being the same. And the one in the middle ends up being unique because, remember, that's our axis of symmetry. Okay? We saw that in the last example too, right? The first and the fifth y-coordinates are the same. The second and the fourth are the same. The center one is unique. Okay. All right, so let's see. X negative 1, y 0. X0, y 3. X1, y 4. X2, y 3. And x3, y 0. All right. So this function produces kind of an upside-down version of a parabola, right? Or of the graphs that we saw previously, right? Instead of it pointing upwards, it's pointing downwards. Instead of a low point in the center, we have a high point in the center. Now, why do you think it's pointing downwards, right? Give you a moment to think about it. But it has to do with the fact that our second degree term was negative, right? That determines whether the function is going to open down or open up, right? If that second degree term is positive or negative. Okay. All right, so our vertex, let's choose a different color this time. Choose orange. Okay, is related to, in this case, the high point on our parabola, which we know is the center coordinates in our table of values. Okay, so 1, 4. Right, we're on the last page now, and all that's really changed here is that we have a coefficient, I guess, that's not 1 nor negative 1, right? We're looking at some quadratic equations or functions that have a coefficient of 2. Okay. But that's really all that's different. The process is exactly the same. All right. So I'm going to label the coefficients A, B, and C. A, B, C. Okay. Evaluate the axis of symmetry. X equals negative b over 2a. So that's going to be the negative of 2 over 2 times 2. Okay. So that is, let's see, negative 2 over 4. So 1/2. Okay, negative 1/2. Interesting. Okay, so it's not an integer. Okay. All right, so let's put negative 1/2 in the center there. Okay. Now, I can choose integers for the other two values, and I probably want to do that, right, just to make the math simple. So let's choose two integers that are just smaller than negative 1/2, so like negative 1 and negative 2. And then we'll choose two integers that are a little bit bigger than 1/2, negative 1/2. So that would be like 0 is the next bigger integer, and then 1. Okay. All right. So let's go ahead and substitute these x coordinates, x values, into our function. All right. So I have 2 times negative 2 squared plus 2 times negative 2 plus 1. I have 2 times negative 1 squared plus 2 times negative 1 plus 1. 2 times negative 1/2 squared plus 2 times negative 1/2 plus 1. 2 times 0 squared plus 2 times 0 plus 1. And 2 times 1 squared plus 2 times 1 plus 1. Okay. and I'm going to go ahead and rely on the calculator here. 2 times negative 2 squared plus 2 times negative 2 plus 1. Okay, so I get 5. 2 times negative 1 squared plus 2 times negative 1 plus 1. That's 1. Okay, 2 times negative 1/2 squared. Right, so you type in negative 1/2 as a fraction, plus 2 times negative 1/2 plus 1. Okay, so that's 0.5, which is 1/2. Okay, 2 times 0 squared plus 2 times 0 plus 1 is 1. And then 2 times 1 squared plus 2 times 1 plus 1 is 5. Okay, so it shouldn't be all that surprising that the first and last y-coordinates are the same, the second and the fourth are the same, and the one in the middle is the one that's unique, right? Remember, that's going to be the one that produces our vertex. All right, so let's start with x negative 2, y 5. Should be right there. Okay. X negative 1, y 1. Should be right there. X negative 1/2, y 1/2. So if I go half a space back and then half a space up, my point would be right there. Okay. X0, y 1. Be right there, and x1, y5 be right there. So I've got that U shape, but it's a little bit narrower this time around. Okay, remember our vertex was right there. All right, so the vertex is kind of that unique point there right in the middle. And the coordinates were negative 1/2 and positive 1/2. Okay, I'll write them as decimals, I guess. Negative 1/2, positive 1/2. All right, we've got one last one. Okay, and hopefully, after we finish this, you have a better grasp on how to graph a quadratic function. Okay. It's just like graphing a linear function. You complete a table of values, you plot the points. There's just this extra step of, determining the axis of symmetry, right? Because for a line, right, no matter where you are on the line, it kind of looks the same. But for a quadratic function, it looks different, right? It looks pretty straight here. It changes direction here, and then it gets straight again, right? So we want to find that point where it changes direction, right? And that's where we want to have our graph kind of focused on that location. Okay. All right, so f of x equals 2x squared minus 4 would be the same as 2x squared plus 0x, right? There's no first degree term, minus 4. Okay, so the a coefficient is 2, the b coefficient is 0, and the c coefficient is negative 4. All right, so x equals negative b over 2a. That's going to be negative 0 over 2 times 2, and that's just going to be 0. Okay, it's really nice when the axis of symmetry produces the value 0. Okay. All right, then we'll pick 2 integers just less than 0, so negative 1, negative 2. 2 integers just bigger than 0, 1 and 2. And then we will evaluate our function. Okay. 2 times negative 2 squared minus 4, 2 times negative 1 squared minus 4, 2 times 0 squared minus 4, 2 times 1 squared minus 4, and 2 times 2 squared minus 4. All right, so let's use our calculator here. 2 times negative 2 squared minus 4. is 4. 2 times negative 1 squared minus 4 is negative 2. 2 times 0 squared minus 4 is negative 4. Okay. And you can probably guess what the next two y coordinates are. I'm going to check on the calculator just to be safe, but keeping in mind this whole idea of symmetry, right? And remember, like the first and the last y coordinates were the same, the second and the fourth. So we should see repeats of these two coordinates. 4 and negative 2 should be down here as well. Okay, so let's just verify that. 2 times 1 squared minus 4 is negative 2, right? Just as we thought. 2 times 2 squared minus 4 is 4. Okay, just as we predicted. All right, so we've got to plot these now. X negative 2, y positive 4, x negative 1, y negative 2, okay. X 0, y negative 4, 1, 2, 3, 4, okay. X1, y negative 2, and x2, y positive 4. So this graph seems to have like the same amount of narrowness as the previous one. And what these two functions had in common is they both had 2 as the coefficient on the second degree term. So that coefficient looks like it's determining how narrow or how wide the parabola opens. Okay, yeah, just something to think about. Now let's find the vertex. Right, our vertex is going to be that point there in the center, and the coordinates are 0, negative 4. All right. So that wraps up our introduction to graphing quadratic functions. You really just want to identify that axis of symmetry first. Okay, create your table of values, plot them like you normally would for any function, linear function, exponential function, whatever. Okay, and then the vertex is just that one special point that is uniquely in the center of the parabola. Right. Thanks for watching. I'll see you in the next video.